Hi, if you remember in the last tutorial, we had a quick look at the shape and form of a wave. In this tutorial, we're just going to have a look at the electromagnetic spectrum. Now, the electromagnetic spectrum can be split up into 7 distinct parts, each one being distinguished by a particular range of wavelengths or frequencies. So on the left hand side we've got the longest wavelength parts of the electromagnetic spectrum, going all the way down to the short wavelengths on the right hand side. So for the longer wavelengths we call these radio waves, followed by microwaves, followed by infrared, followed by visible, and it gets shorter and shorter as we go down to ultraviolet, X-ray and the high energy gamma rays. There were the shortest wavelengths. So let's have a look at the wavelengths. If we look at radio waves, they can be quite big actually. They're talking like kilometers to meters in length, in that kind of range, about the size of buildings. Microwaves, now they're getting smaller, about the size of like insects and butterflies, stuff like that. Infrared radiation, even smaller still in wavelength, looking like the tip of a needle or something like that. Now, if we get onto the visible part of the spectrum, now we're approaching like the size of cells. So protozoa is a good example that's often used. Ultraviolet radiation, now we're getting to the size of molecules, 10 to the -8 meters. X-rays, even shorter wavelengths, now getting to the size of the atom. We're talking about the width of the atom, if you will. And gamma rays, they approach the size of the nucleus. So hopefully that's give you a good idea of the scale of the electromagnetic waves and how they can be related to everyday objects like buildings and atoms. Alright, that's not an everyday object, I know, but hopefully you know what I mean. And also how the wavelength is directly linked to the frequency, and how the frequency will give you some kind of indication as to the energy of the particular wave that's being studied. For example, radio waves don't have a lot of energy associated with them, but gamma rays, because of their short wavelength and high frequency, will have a lot of energy associated with them. So that's it for now. Bye for now.